When we talk about NASA missions, we celebrate the astronauts, the brave souls strapped to rockets drifting through the void, becoming the faces of human exploration. We remember their quotes, their courage, their iconic steps on alien worlds. But behind every footprint on lunar dust, behind every orbit, every launch, every safe return, stood thousands of hidden heroes working far from the spotlight. These were the engineers, the quiet warriors of space. They didn't wear spacesuits or float in zero gravity. They wore headsets, badges, and exhaustion. They worked in silence, surrounded by blinking panels, endless data streams, and the constant pressure that one mistake could cost a life. They weren't chasing fame. They were chasing precision, chasing answers, chasing survival. Every mission they touched became a battle between physics and possibility. And in the darkest moments, when spacecraft malfunctioned, when alarms screamed, when astronauts whispered fear into their microphones, it was these unseen minds who stepped forward. Not with panic, but with calm. Not with guesses, but with solutions no one else could see. They carried the weight of missions on their shoulders, fueled by equations, instincts, and decades of discipline. They were the ones who calculated impossible trajectories in minutes, who patched life-saving workarounds out of thin air, who refused to let failure write the story of humanity in space. These engineers didn't just support history. Every successful landing, every miracle comeback, every mission accomplished began with them, in rooms the world never saw, at desks where they rewrote fate. So the next time we talk about NASA's greatest triumphs, remember this. Astronauts made history, but hidden engineers made history possible. Most people remember the rocket launches, but very few remember the people who built the systems that made those miracles possible. Hidden behind thick walls and restricted doors were the engineers whose brilliance powered every triumph. These were the minds who predicted failures before they happened, who calculated risks to the decimal, who designed solutions long before astronauts ever suited up. Their thoughts were the real engines, their equations, the fuel, their precision, the heartbeat of every successful mission. From the earliest days of NASA, long before rockets pierced the sky, engineering rooms were alive with pressure. Phones rang, papers shuffled, monitors flickered, deadlines loomed like storms. Yet inside those rooms, something remarkable happened. The louder the pressure grew, the calmer the engineers became. They didn't flinch. They didn't panic. They understood something the world never saw. Space is unforgiving, merciless, and absolutely intolerant of error. Up there, one loose bolt can end a life. One incorrect number can turn a mission into tragedy. One unnoticed vibration can tear apart a spacecraft at 17,000 miles per hour. And because they knew this, their work demanded more than knowledge. It demanded perfection. It demanded discipline sharpened over years, instincts built from failures, and a level of focus that bordered on superhuman. These engineers lived in a world where trust wasn't optional. Every calculation had to support another. Every decision depended on someone else's accuracy. Every system, every wire, every line of code held the weight of a human life. If one person slipped, everything slipped. And yet, time after time, mission after mission, they delivered. They turned chaos into clarity. They turned risk into safety. They turned the impossible into the routine. So when the world watched rockets rise into the sky, when children dreamed of becoming astronauts, when history unfolded on screens across continents, it was these hidden heroes who made it all real. Their hands never touched space, but their minds shaped it. Their work didn't just support missions, it made survival possible. During the Apollo era, engineers were asked to do the impossible. Not the difficult, not the ambitious, but the impossible. NASA was racing a ticking clock, trying to reach the moon with technology that today feels almost prehistoric. There were no advanced computers, no modern software, no digital simulations. Instead, these engineers built spacecraft with pencils in their hands, slide rules on their desks, and courage in their hearts. They trusted mathematics more than machinery, knowing that numbers wouldn't lie, even when hardware might. Every launch became a leap of faith, a gamble where human lives hung on calculations scribbled in notebooks and formulas etched into chalkboards. These were people who pushed metal, physics, and possibility far beyond their limits. They weren't designing spacecraft that could fly to the moon. They were designing the first machines in human history that ever would, with no roadmap, no precedent. no margin for error. And each time a rocket roared off the launch pad, each time a capsule pierced the darkness, it was their silent courage that made it possible. The NASA true power didn't come from individual brilliance. It came from the machine behind the machine. It's a relentless system of collaboration. Inside NASA, thousands of engineers operated like interconnected neurons firing in perfect harmony. Mechanical teams obsessed over gears, structures, and moving parts. Electrical teams tracked currents, wiring, and the invisible lifelines that powered the spacecraft. Propulsion teams calculated the raw fury of engines capable of shaking the Earth. Life support teams designed the systems that kept astronauts breathing, drinking, and surviving in a place where nothing was meant to live. These teams didn't compete. They connect. Every department depended on the others. Every piece of hardware meshed with another. Every decision rippled across the entire mission. A change in one system meant adjustments in all others. A tiny oversight anywhere could bring everything crashing down. Trust wasn't a luxury, it was a requirement. Yeah. This synergy, this beautifully orchestrated teamwork, became the backbone of every mission that left Earth. The success of Apollo wasn't the story of a few heroes. It was the story of thousands, working as one mind, one heartbeat, one unstoppable force that carried humanity to the moon. One of NASA's greatest silent legends was a young, brilliant computer engineer named Jack Garman. A man whose name most people never hear, yet whose quick thinking shaped the most important mission in human history. Apollo 11. On the day mankind attempted its first lunar landing, millions watched with shaking breath, but inside mission control, the pressure was crushing. As the lunar module descended toward the moon, its tiny onboard computer suddenly overloaded. Warning alarms, ones no astronaut ever wanted to hear, it began exploding across the screens. Confusion erupted. Voices rose, panic clawed its way into the room. But in the middle of this chaos sat Jack Garman, calm as still water, young, sharp, and intensely prepared. He scanned the flashing error codes and recognized them instantly. To anyone else, they looked like disaster. To Garman, they were familiar. He had spent years of his life rehearsing every single alarm, every failure mode, every nightmare scenario the lunar computer could produce. He didn't guess. He didn't hope. He knew exactly what those alarms meant. In that moment, while the world teetered on the edge of losing the moon landing, Garman leaned into his microphone and declared the words that saved the mission. Go. They're safe to ignore. Those 5 calm words became the difference between triumph and tragedy. Neil Armstrong and Buzz Aldrin were seconds away from being forced to abort the landing. One moment of hesitation, one incorrect call, and humanity's greatest achievement would have slipped away. But because Jack Garman was ready, because he had trained his mind to respond under impossible pressure, the mission continued. His composure came from discipline. His certainty came from preparation. Garman knew that astronauts had only moments to act, and mission control had even less. He understood that fear could cost history. So he replaced fear with knowledge, doubt with confidence, and panic with precision. And because of that, Neil Armstrong kept descending. The lunar dust rose beneath the Eagle. Humanity touched the moon for the first time. Jack Garman never walked on the lunar surface. He never became a household name. But without him, that giant leap might never have happened at all. Another hidden hero of the Apollo era, one whose brilliance shaped the very heartbeat of the mission, was Margaret Hamilton. While the world watched astronauts train in suits and simulators, Margaret worked late nights surrounded by stacks of handwritten code taller than she was. Her battlefield wasn't space. It was logic, algorithms, and the fragile brains of early computers. She wasn't just programming. She was protecting. Every line of code she wrote was designed to anticipate disaster before it happened. She built systems that could override dangerous commands, systems clever enough to save astronauts from their own mistakes. Systems that treated errors not as failures, but as warnings. In an age where computers were weak, tiny, and temperamental, Margaret engineered a mind inside the machine, one smart enough to survive the chaos of space. She was decades ahead of her time. Her most groundbreaking creation was an algorithm now known as priority scheduling. It gave the Apollo guidance computer something revolutionary. No other spacecraft computer on Earth could do this. No other engineer even imagined it. And then came the day her brilliance proved essential, Apollo 11. Lunar descent, the world holding its breath, suddenly alarmed. The computer was overloaded, screaming warnings that filled mission control with fear. The landing was seconds from being aborted. The moon was slipping away. But Margaret's code was ready. Her algorithm immediately threw away non-essential tasks, freeing the computer to guide the lander safely. It kept Neil Armstrong's path steady, giving humanity the chance to take that legendary first step. Without Margaret Hamilton's foresight, the most iconic moment in human history, the moment mankind touched the lunar surface, might have ended in failure. She didn't wear a spacesuit. She didn't fly the spacecraft, but her mind kept it alive. And because of her, the Eagle landed. Apollo 13 wasn't just a mission, it was a battle for survival. When that oxygen tank exploded, ripping through the spacecraft with terrifying force, everything changed in an instant. The lights flickered, the alarm shrieked, and 3 astronauts suddenly found themselves drifting through space inside a wounded ship. There was no manual for this, no checklist, no past mission to look back on. NASA had never seen a failure like this before. Every system the crew depended on was dying. And yet, on the ground, an army of engineers rose to meet the impossible. Inside mission control, the atmosphere was electric with fear. Each second felt like a countdown to disaster. But the engineers did something extraordinary. They refused to panic. They knew that emotional reactions could cloud judgment, and clouded judgment could kill the astronauts faster than the explosion ever could. So, they wiped the fear from their faces, steadied their voices, and focused on what they did best: solving problems that no one had ever imagined. They worked like surgeons operating on a patient with no pulse, inventing solutions faster than the spacecraft leaked air. They pieced together life support systems from scraps. They rebuilt checklists from memory. They calculated new flight paths using math scribbled on coffee-stained notepads. Every idea, every wire, every patch was a lifeline thrown across 200,000 miles of empty space. Flight Director Gene Kranz became a symbol of calm leadership during this chaos, his white vest glowing under the fluorescent lights like a beacon. But even Kranz would tell you, he was only one voice in a sea of brilliant minds. He stood at the front, but behind him were thousands of engineers, each fighting to keep 3 lives alive with nothing but creativity and determination. A failure is not enough. The world remembers that line, but the truth is, the line only worked because NASA engineers already believed it. They had no intention of letting failure win, not on their watch, not on the watch of the countless men and women who had dedicated their lives to exploration. And so together they turned a catastrophe into one of the greatest rescues in human history. Apollo 13 didn't return home because of luck. It returned because of ingenuity, discipline, teamwork, and the unbreakable willpower of NASA hidden heroes. As carbon dioxide levels crept higher inside Apollo 13, a horrifying realization spread through mission control. The crew was slowly poisoning themselves. The command module and the lunar module used 2 completely different CO2 filters, and the only ones still working were the wrong shape. The astronauts had air to breathe, but no way to clean it. It was like being trapped in a sealed room while the oxygen vanished inch by inch. Time was slipping away, and every breath the crew took brought them closer to death. Engineers didn't have the luxury of waiting. They had to invent a solution, not tomorrow, not in an hour, right now. And they could only use items already on board the spacecraft. No new parts, no tools. So they dumped everything they could find onto tables: hoses, cardboard panels, plastic bags, socks, manuals, duct tape, anything the astronauts had. The room looked less like a high-tech space agency and more like a chaotic hardware workshop. But inside that chaos, brilliance began to form. Engineers sketched, cut, taped, tested, and rebuilt. They argued, solved, and solved again. And in the blur of pressure and creativity, they designed something nobody had ever thought of: a square filter that could fit into a round hole. A makeshift CO2 scrubber crafted from scraps. A literal life-saving invention made from plastic, cardboard, and pure human determination. When the astronauts assembled it in space and clean air began to flow again, mission control didn't cheer. They exhaled, the first real breath of relief in hours. But the crisis wasn't over. Another team faced an equally deadly challenge: The command module was shut down, cold and lifeless. Restarting it the wrong way could overload the system. A few extra watts, the power of a single household light bulb, could fry its circuits. Too few watts and the ship would stay dark, freezing the astronauts to death. So engineers built a power-up sequence down to the tiniest detail. They calculated every watt, every switch, every second. It was mathematical surgery performed under unbearable pressure, and because of that precision, because of those minds working through exhaustion and fear, the command module flickered back to life. Apollo 13 had a path home. The world calls it a miracle. NASA calls it engineering. Apollo 13's journey home wasn't just a test of courage in space. It was a test of ingenuity on Earth. With the spacecraft damaged and computers offline, the astronauts had no choice but to rely on manual calculations for every critical maneuver. And those calculations weren't simple. Every trajectory correction, every engine burn, every angle had to be exact. Too much thrust and they would overshoot Earth. Too little and they would drift forever into the void. Propulsion engineers stepped into the breach, performing miracles under unimaginable pressure. They scrawled equations across whiteboards, erased and recalculated with trembling hands, and devised burn angles no human had ever tried before. Every number, every decimal, every fraction became a lifeline, guiding Apollo 13 safely through the vacuum of space back toward home. These weren't just calculations. They were acts of survival, moments where mathematics and human life intersected. Meanwhile, other engineers sat at their consoles, eyes bloodshot, bodies rigid from days without sleep. Some hadn't left their chairs since the explosion. They didn't rest. They didn't complain. Every line of telemetry, every spark of sensor data, every reading had to be verified. A single miscalculation could cost 3 lives. Their exhaustion was irrelevant. Their mission was clear: keep the astronauts alive. These engineers' heroism was invisible, hidden behind screens, buttons, and blinking lights. Yet it was no less courageous than the astronauts who floated through the crippled spacecraft. While the astronauts faced the emptiness of space, these engineers faced the emptiness of uncertainty, armed only with their knowledge, their determination, and the unwavering belief that failure was not an option. Because of their tireless work, Apollo 13 followed the path plotted by human minds, not just machines. Because of their precision, ingenuity, and sheer willpower, the spacecraft executed burns, corrected its trajectory, and edged closer to home. These engineers never left mission control, yet they traveled further than most, through fear, exhaustion, and impossible odds, to ensure that the crew returned alive. In the story of Apollo 13, they were as heroic as the astronauts themselves. Their silent courage, their relentless calculations, and their unwavering focus were the invisible engines that guided humanity safely back from the brink of disaster. When NASA entered the Space Shuttle era, engineers were handed a challenge unlike anything the world had ever attempted: to design a reusable spacecraft. Unlike the one-time rockets of Apollo, this vehicle had to survive launch after launch, re-enter Earth's atmosphere without melting, and land safely like an airplane. It was a machine the world had never seen before, and it demanded innovation that pushed engineering to its limits. Every component, every calculation, every material had to be perfected because there was no margin for error. One of the shuttle's greatest engineering puzzles was its thermal protection system. Engineers developed thousands of tiles, each designed to withstand the extreme heat of re-entry, temperatures hotter than molten rock. They were feather-light, fragile, and painstakingly crafted. A single missing tile or one installed incorrectly could allow searing heat to breach the shuttle's skin, destroying the vehicle and everyone inside. Engineers worked with obsessive precision, inspecting each tile, testing every edge, ensuring nothing was left to chance. The stakes could not have been higher, but thermal tiles were just one piece of a much larger puzzle. Electrical engineers faced their own impossible challenge, designing fault-tolerant systems with multiple backups. In space, a single failure could be catastrophic. Layers upon layers of redundancy, systems that could take over if one failed. Then another, then another, then another. Every switch, every circuit, every sensor was tested relentlessly. These engineers created a web of safety so reliable that astronauts could trust their lives to it, even when traveling 17,000 miles per hour through the vacuum of space. The work required collaboration on an unprecedented scale. Mechanical engineers, thermal specialists, propulsion experts, and electrical teams worked together like parts of a single mind, checking each other's calculations, challenging assumptions, and iterating designs until perfection was achieved. Each shuttle mission depended not just on astronauts, but on thousands of invisible hands and brilliant minds working tirelessly to prevent disaster. NASA engineers didn't just build a spacecraft. They reinvented what was possible. They created machines that could survive forces humans had never experienced, navigate environments humans could barely imagine, and return safely to the planet below. Their careful planning, ingenuity, and tireless effort gave astronauts layers of safety, layers of trust, and turned the dream of a reusable spacecraft into reality. When the Challenger disaster struck in 1986, the world watched in shock as the shuttle exploded just 73 seconds after liftoff. Families, colleagues, and millions of viewers felt the pain of a tragedy that seemed impossible. But behind the heartbreak, it was NASA engineers who quietly took the lead, facing a different kind of pressure, uncovering the truth. They combed through debris, examined data, and pieced together the events that had caused the catastrophic failure. Their work was painstaking, technical, and emotionally exhausting. Many of these engineers had already warned NASA about the dangers of launching in freezing temperatures. They understood that the O-rings on the solid rocket boosters could fail under extreme cold. Their concerns had been raised, documented, and ultimately ignored. When the disaster occurred, their worst fears were confirmed. Yet, instead of retreating into despair, these engineers became the architects of accountability. Their persistence ensured that lessons would not be forgotten, and that the same mistakes would never be repeated. After Challenger, engineers became more than technical experts. They became the moral backbone of NASA. They demanded transparency in decision-making, insisted that safety could never be compromised, and required evidence to support every launch. No longer would schedules dictate risk. No longer would authority silence caution. They rebuilt confidence from within, creating a culture where concerns could be voiced, analyzed, and acted upon. This shift transformed NASA. Engineering teams were empowered to speak up, to double-check, and to question assumptions. Safety protocols became stricter, redundant systems were enforced, and communication between departments was strengthened. Engineers' expertise and courage reshaped the agency, making every launch after Challenger a testament to lessons learned the hardest way. The Challenger tragedy reminded the world that space exploration is unforgiving. But it also showed that engineers aren't just problem solvers. They are guardians of human life, carrying the responsibility of every mission, every astronaut, every dream into the future. Their voices, once ignored, became the foundation upon which safer journeys could be built. NASA survived Challenger not because of luck, not because of courage alone, but because engineers refused to let failure define. They transformed heartbreak into reform and fear into vigilance, proving that the invisible hands behind the missions were as vital as the astronauts themselves. Some of NASA's most powerful contributions didn't come from astronauts in spacesuits, but from women working quietly behind the scenes. Katherine Johnson, Dorothy Vaughan, and Mary Jackson shattered barriers, not with headlines or fame, but with sheer genius and unwavering determination. Their brilliance made early spaceflight possible, and their influence continues to shape the modern space program. Katherine Johnson was a mathematician whose calculations became the heartbeat of NASA. She mapped trajectories for America's first orbital missions, ensuring that spacecraft launched, orbited, and returned safely. Her work was so precise that astronauts often trusted her numbers more than the computers themselves, machines that were still in their infancy. Each equation she solved, each trajectory she verified, carried human lives across the void of space. Katherine wasn't just calculating paths, she was safeguarding humanity's first steps beyond Earth. Dorothy Vaughan was a pioneer in her own right, mastering computer programming just as NASA entered the digital age. She saw the future before it arrived and prepared a generation for it. Dorothy trained countless women to code, ensuring that NASA workforce could meet the challenges of increasingly complex missions. Her leadership extended beyond technical skill. She inspired confidence, resilience, and ambition in everyone around her. Through her vision, the space program gained both innovation and inclusion, proving that talent knows no gender. Mary Jackson transformed the field of aerodynamics through tireless research in wind tunnels. She solved problems that directly influenced spacecraft stability, flight paths, and re-entry safety. Every experiment she conducted, every data point she analyzed, became a brick in the foundation of NASA engineering excellence. Her perseverance broke both professional and social barriers, showing that intelligence and determination could overcome even the strictest limitations. Together, these women exemplified courage, intellect, and resilience. They weren't just contributors to NASA. They were architects of its success, laying the groundwork for generations of engineers, scientists, and astronauts. Their stories remind us that heroism isn't always visible on camera or celebrated in headlines. Sometimes it is found in the quiet brilliance of those who calculate, code, and test behind the scenes. Katherine, Dorothy, and Mary proved that the engines of space exploration aren't only rockets and computers. They are the minds, the determination, the unwavering courage of the people who make humanity's reach for the stars possible. Behind every spacecraft, beyond every trajectory calculation and software line, stood a group of unsung heroes, NASA technicians. These were the hands that turned dreams into reality, the craftsmen who transformed blueprints and diagrams into vehicles capable of surviving the unforgiving vacuum of space. They weren't in the spotlight, they didn't appear in headlines, but without them, no mission would ever leave the ground. Technicians meticulously assembled circuits, installed sensors, and secured miles of wiring. They bolted panels, calibrated instruments, and tested every system until it performed flawlessly. Every connection had to be perfect, every sensor precisely positioned, because in space, even the smallest imperfection could become catastrophic. Their work was exacting, repetitive, and often invisible, yet it carried the weight of human lives and national ambitions. Many worked in pristine clean rooms where the air itself was filtered to eliminate dust, and every movement was controlled. A single smudge on a delicate surface, a stray fingerprint, or a misplaced screw could doom an entire mission. They moved with quiet precision, following strict protocols, not because they wanted to, but because they had to. Each action mattered. Each decision was measured. Each test could be the difference between triumph and tragedy. Hours turned into days, and days into nights as technicians labored tirelessly to prepare spacecraft for launch. Their hands grew calloused, their eyes strained, yet they never lost focus. They were the guardians of perfection, ensuring that every spacecraft could withstand the brutal extremes of temperature, radiation, and acceleration it would face on its journey beyond Earth. While the world celebrated rockets, astronauts, and historic milestones, these technicians remained largely unseen. Their craftsmanship, patience, and unwavering attention to detail made space exploration possible. Every mission's success bore their fingerprints, literally and figuratively, etched into every panel, circuit, and sensor. And the story of NASA, technicians weren't just workers. They were essential architects of survival, shaping the vehicles that carried humanity into the stars. Their dedication reminds us that space exploration is not only about courage and genius, but also about precision, discipline, and the quiet heroism of those who build the dreams that others live out among the stars. Space is unforgiving. Beyond Earth's atmosphere, there is no air, no warmth, no mercy. Every mission depends on the invisible work of specialized engineers who protect astronauts from hazards most people cannot even imagine. Environmental engineers were among the first line of defense, meticulously overseeing oxygen, pressure, and contamination systems. They didn't just design machines, they designed life itself. They developed emergency procedures for disasters so improbable that few dare to think of them, yet they planned for every scenario. Their work ensured that astronauts could breathe, move, and survive while hurtling through the void. Communication engineers worked in a different kind of silence. They built deep space networks capable of capturing the faintest signals from millions of miles away. Every transmission, every heartbeat, every word from the spacecraft depended on their technology. They were the invisible link between humanity on Earth and the pioneers exploring the cosmos, holding the fragile thread of connection taut across the emptiness of space. Thermal engineers faced a world of extremes. They protected spacecraft from temperatures hotter than molten rock during re-entry and colder than the void of interstellar space. They designed insulation, cooling systems, and heat shields tailored to conditions no human had ever experienced. Without their ingenuity, every spacecraft would fail long before leaving Earth's atmosphere. Their calculations turned metal shells into vehicles capable of surviving fiery descent and freezing orbit. And then there were the life support engineers, tasked with the impossible, turning small metallic capsules into livable homes in a place where nothing could live. Every breath, every drop of water, every degree of temperature, every bit of humidity and CO2 had to be precisely controlled. They transformed raw machinery into ecosystems that could sustain life, often working in near silence, relying on decades of knowledge, intuition, and meticulous design. Without them, astronauts would be stranded in space, exposed to the lethal environment beyond our planet. Together, these engineers created the invisible infrastructure that allowed humanity to explore beyond Earth. Their expertise was as vital as courage in a spacesuit, as critical as the rockets themselves. While the world celebrated astronauts and launches, it was these minds, calculating, designing, safeguarding, who kept humanity alive among the stars, making every journey possible. Every successful NASA mission, every launch, every landing, every step into the unknown was built on the invisible brilliance of engineers. These were the people who solved problems the world never heard about, who turned theoretical nightmares into practical solutions, and who carried the weight of human life on their shoulders without ever stepping into the spotlight. Their reward wasn't fame, applause, or headlines. It was the quiet satisfaction of knowing that their work protected astronauts, safeguarded missions, and turned impossible dreams into reality. NASA culture didn't just value brilliance. It valued learning from failure. Mistakes were not punishable offenses. They were opportunities to improve. Engineers studied every error, every anomaly, every misstep with meticulous attention. They dissected problems, recalculated, tested, and rebuilt, turning setbacks into stepping stones for progress. This mindset of relentless analysis and iteration transformed NASA into a crucible of innovation, a place where human ingenuity could thrive even under unimaginable pressure. Today, the legacy of those early pioneers lives on in a new generation of NASA engineers. These modern problem solvers combine the timeless principles of careful calculation, discipline, and creativity with cutting-edge technology. Artificial intelligence, robotics, advanced materials, and autonomous systems. They are designing spacecraft for the moon, rovers for Mars, and satellites for destinations even further into our solar system. Every mission carries their fingerprints, invisible but essential, as they expand humanity's reach into the cosmos. From the Artemis program to Mars exploration rovers, engineers remain the silent force behind every step of space exploration. They build machines that endure storms, dust, radiation, and the relentless passage of time, conditions no human could survive. They craft life support systems, navigation software, propulsion mechanisms, and communication networks that extend humanity's presence into environments far beyond our natural reach. Their brilliance allows us to explore safely, boldly, and continuously. The astronauts may be the faces we see, the ones who walk on alien surfaces and reach for the stars. But it is the engineers, past and present, who make those journeys possible. They are the quiet architects of survival, the guardians of progress, and the invisible hands that carry humanity forward. Without them, exploration stops. With them, humanity reaches for the stars. The public sees the final moments, the launches, the landings, the celebrations. They see astronauts stepping into the unknown, rockets soaring into the sky, and triumphant waves back to Earth. But what they rarely see are the thousands of hours, the sweat, the calculations, and the relentless focus that made those moments possible. Every victory in space exploration is built on invisible labor. Every success belongs to people whose names never appeared in headlines, whose faces never graced magazine covers, but whose work carried humanity into the stars. NASA's story is more than astronauts and iconic missions. It is the story of people who believed that math, science, and sheer determination could conquer the impossible. It is the story of engineers who transformed theory into reality, who turned problems with no precedent into solutions that saved lives. Their dedication, ingenuity, and discipline remain one of NASA's greatest strengths, quietly ensuring that humans can survive where no one else could. These engineers were not astronauts, yet they saved missions. They were not famous, yet they protected the future. They were the silent guardians of space exploration, standing between disaster and history, between impossibility and achievement. Without their tireless work, humanity would have remained earthbound. Dreams of the moon, and beyond forever just that, dreams. Their lesson is simple but profound. Greatness is not found in the spotlight, but in service. Saving lives doesn't always require a spacesuit. Sometimes all it takes is a pencil, a calculation, a spark of creativity, and the courage to never give up. These are the qualities that turn fragile spacecraft into vessels of survival, calculations into trajectories, and raw courage into history. And today, every mission to the moon, Mars, and beyond carries their fingerprints. Every rover, every capsule, every orbital experiment is built on the foundation laid by these hidden heroes. Their stories inspire the engineers of tomorrow. Their legacy lights the path for humanity's next giant leap. So when we celebrate the triumphs of astronauts, rockets, and milestones, let us also remember the invisible hands, the brilliant minds, and the courageous hearts that made it all possible. Because true heroism is often quiet, unseen, and measured not in applause, but in the lives it saves and the history it creates.